Okay, let's consider this question. Given f at x is equal to negative ax squared plus bx plus c. So we have 4.1 here, which says the gradient of the tangent to the graph of f at a point this is equal to 3. So now we are given the gradient of the graph, which is f. At this specific point, the gradient is equal to 3. So now the question says, so show that the value of a is half and the value of b is 2. So how do we go about doing this? The fact that the point is given, the first thing that has to come to our mind is substitution. So let's first substitute using this point in our equation and see what do we obtain. So now what are we having? We have f at x is equal to negative x squared, then plus bx, then plus 6. So let's try to substitute by that point. In the place of y, we're going to put 7 over 2, which means here we have 7 over 2. Then we have negative a. Then in the place of x, we're going to put negative 1, which is negative 1, but it is being squared. Then plus b times negative 1, then plus 6. So if we can do the simplification, taking this one to the other side, then this one's being simplified, you'll see that you get 7 over 2 plus minus 6, you get 5 over 2. Then this is going to be equal to, this thing squared is going to be positive, then therefore you'll be having negative a, then minus b. So I think this one can be regarded as a first equation because we do have two unknowns, which means we need two equations to solve those two unknowns. So let's consider the second equation. How can it be found? Remember that we took the gradient of the tangent to a graph of this f at x. We know now when the graph of f is given, to find the gradient is the same as to find the derivative of the gradient, because the derivative of the gradient is just the gradient of the function, but it can just be in terms of a respected variable. So that drives us to the derivative of f at x, which is going to be f prime of x, which is going to be equal to now negative 2ax, then plus b. So after finding the derivative of this kind of thing, then we are going to substitute now by what we have. Remember now, this is the gradient. This is the derivative. This is the gradient. So in the place of the gradient, we can just put 3. Then therefore, this is equal to, then we have negative 2, then a. In the place of x, we put this negative 1, remember? Then we have negative 1, then plus b. So solving for b, you will see that we are having a b, which is equal to, then we have 3 minus your calendar is going to be what? 2a. So you can see that this is the simple equation number 2. Now, after finding these two equations, we can solve simultaneously. Otherwise, this b is already a subject of the formula. Then we can take all what we have here and substitute straight to the value of b there. So that means we are going to be having negative 5 over 2, which is equal to negative a. Then in the place of b, we're going to put 3 minus 2a. Okay, because this is our b and this is our b. So in the place of b, we put that. So if we can do the distribution process, which is going to be negative a, then negative 3, then plus 2a. Alright, because this negative times this negative gives us what? Gives us a positive number. So after having this, we're going to have this negative 2a minus a is going to be just going to be equal to 2. Then we'll take this positive, this negative 3 to the other side. You will basically get you'll get a is equal to just half. Okay, so if we take this half and substitute straight to where b was, then therefore minus 2 in the place of a, we put this variable, then therefore we have 1/2. Then therefore our b, if this cancel that, then we have -1, then 3 minus 1 is just going to be 2. So we did show that a is equal to half and b is equal to 2. So coming to the next question, if you really don't have a question here, you can just go to the next question.